Okay, so now we are going to start our today's topic, and our today's topic, actually, the main topic is molecules and matter. Okay, molecules and matter. Okay, so first, let me explain you a little about the molecules. That what is the meaning of the molecules? Do you have any idea?
Is it two of the same atoms?
Yeah, it is not necessary that two same atoms. For example, we know that the matter actually made of atoms, isn't it?
Yes.
Matter is made of atoms. Okay. And atoms are, you can say, the tiniest parts of matter. And then the combination of two or more atoms that actually make one molecule. Okay. Understand?
Yeah, I
And
was talking
then,
about molecule.
sorry, second.
I was talking about molecule.
Yes. So then it is not actually the necessary that if these atoms must not be, you can say, the identical, they can be different. For an example, that when we say that we have water, and here we have two hydrogen atoms and one oxygen atom. So this is one molecule of water, isn't it? Because there
Yes.
are the two different elements, hydrogen and oxygen. Okay. And then our actually, because we will be discussing mainly the physics, not the chemistry of the matters. So then we will measure the density. Okay, first of all, the first thing that we need to measure is density. What is the meaning of density? Density, let's we represent it with the rho. The density is the measure of, you can say that from the word, actually the density, it is also very clear, it's intuitive that you are going to tell that how dense some material is. What does it mean? It means that how much mass we can put at some given volume. For an example, that you are filling and your this dustbin. Okay, so this dustbin will have some, you can say, the volume, and what you do, you put your garbage in this dustbin, and when it will be filled, what would you do? You press it, isn't it?
Yes.
You are pressing it. When you are pressing it, then it is giving you more space, more volume. That means that you can put more mass here. What are you doing? You are actually making it dense, isn't it? You are making it dense. What does it mean? It means
Yes.
that the mass in this volume is increasing, isn't it? The mass in this volume is increasing. So this in fact also, you can say, giving us a mathematical formula, and that mathematical formula of density is that the mass per unit volume, isn't it? The mass per unit volume.
Yeah.
Okay, so this volume, if you will, for example, so now we do have a three things, and we can write it purely mathematically that rho is equal to m divided by v, and the units of density will be then kilogram per meter cube, because the units of volume are meter cube. Now these are three parameters, those are connected with each other, that if, for example, you keep your mass constant, then by increasing this volume, what would happen to the density if you increases the volume?
It will decrease.
Yes, if you will increase the volume, the density will decrease. And if you decrease your volume, density will decrease, because these are inversely proportional. And on the other hand, that this density and mass, they are directly proportional to each other, directly proportional to each other. Now, for example, we actually got a question. The question is that a wooden post has a volume of, that the volume V is given, for example, 0.025 5 meter cube. Okay, this is the volume. And the mass of 20 kilogram. The mass is 20 kilogram. Okay. So now what we need to calculate? We need to calculate the density, and we need to calculate the density in kilogram per meter cube, for example. So then it is very simple and straightforward, because we know that this density is equal to what? The mass. This is in kilogram, because we are asked to calculate in kilogram per meter cube. So then this will be simply 20 divided by 0.025, isn't it? So our answer will be equal to 800 kilograms per meter cube. Okay. Now here I actually have another, you can say, the question related to this, that what I want to do, I want to calculate this density in gram per meter cube. Then how I can actually change these kilograms per meter cube into grams per meter cube?
Uh, so what
Mhm.
you would do is change 20 kilograms
So you
into
see,
grams,
so
which
you
we times that by thousand.
So yeah, you are right. But here, actually, you see, we already have this answer, and this answer we can just change it. How we can change? We know that these are kilograms, and 1,000 grams are equal to 1 kilogram, isn't it? And
Yes,
then 800 kilograms will be equal to 800,000 grams, isn't it? So then our answer will be 800 thousands grams per meter cube. Okay, this is the meter cube. Now, if I say that what I want to do, I want to calculate the density in gram per centimeter cube. Then what I have to do? You have to be very careful in this conversion. We know that 1 meter is equal to 100 centimeters, isn't it? Sorry, this is not, we should not write this. Okay, so then here it is equal to centimeter, like that. Now, because we are measuring in centimeter cube and meter cube, then we can take the cube of both sides. Then 1 meter cube, because cube of 1 is equal to 100 and its cube, and then that will be centimeter cube, isn't it?
yes,
Yes. So here we will say this is equal to 800 thousands divided by 100 3 times, isn't it?
yes,
So now we can actually simplify it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And it means 8 over 10. Answer is 0.8 grams per centimeter cube. Understand?
yes,
Very good. So now we ask, for example, a question. The question is that how we can measure density of something experimentally. How how we can actually do this. So you can actually simply say that the answer is simple. The simple answer is that if we know the mass, if we know mass of that object, and we also know the volume, we can measure simply the density, isn't it? So this is very straightforward. So now if for an example I have a cube of some material, and that cube will be like this, and we can easily calculate the volume of this, actually the cubic object. Okay, so if for example we say that this is a cube with two and the mass of this object is, for example, 5 kilogram. So then in that case, what will be the density of this cube?
It would be 5 divided by 8.
Yes, 5 divided by 8. Okay. Now I have, you can say, the some material which is actually not in a proper shape. It is in this shape. Okay. What I know its mass. I know its mass. Then how you can calculate its density? Because it's very easy to scale the mass. You can put it on the scale and you can measure its mass in kilogram, and then what will be the volume of, you can say, the irregular shaped object? This is a problem, isn't it?
Yes,
Can you calculate the volume of this object?
yeah,
Hmm. Hmm. How?
by putting it into a beaker and then measuring how much water will come out of it.
Very good. So then what we can do, we can have some beaker, and that beaker, or you can say, is a graduated cylinder like. So graduated means that we actually know the volume of this, actually, the, you can say, the I don't know if my drawing is really beautiful or not. So this is like this, isn't it?
Yes,
So, and then here we actually already have marked its volume. Okay, we have marked its volume. Now, if we, for example, say that we have filled it up till this point, and up to this point, the volume of this liquid is, let's say, is 50 centimeter cube. Okay, for example. And then we put this object in, and by putting this object in, the volume will increase, isn't it? Then now
yes,
it is, for example, 770 centimeter cube. The difference between the final value of the volume to the initial value of the volume is in fact the volume of our object, isn't it? Isn't it?
yes,
Yes. So then this is actually the way to calculate the density of any object, any given object. Okay. So now we can go quickly to some exam questions. So exam questions are like, for example, they say that we do have the question number one, and I am pretty much sure that my master Shifu of physics will be very quick to answer. So what we have a rectangular shaped object, and this rectangular shaped object is, let's say, like this, and its length is zero point 0.8 meters, and its width is like, let's say, zero point 0.6 meters, and its height is 0.05 meters. Okay, then answer is the question is that calculate the density, and calculate the density in kilograms per meter cube. And if the weight of this object, sorry, not weight, the mass of this object is a 60 kilogram.
the density would be 2,500 kilograms per meters cube.
Mhm.
Yeah, that's the density.
So how much? So what you did, you actually simply the 60 divided by actually the volume, isn't it?
Yes,
Yes. So this is the answer in kilogram per meter cube. And if we want to calculate it into the centimeter cube, for example, kilogram per centimeter cube. So what we would do, we actually divide it by, this is 80 centimeters, isn't it?
Yes.
and this is 60 centimeters, and this one is the 5 centimeters, isn't it?
Yes.
So 60 gone with the 60, and you can calculate it rest very easily. Okay, now the next question is the following. uh, I would write this question quickly here, that a measuring cylinder, a measuring cylinder contains 80 centimeter cube of a particular particular uh, liquid. The liquid is poured into an empty beaker, okay, of mass 48 grams. So this is actually the mass of the beaker. Okay, the total mass of the beaker and the liquid is uh, 136 grams. Okay, now we have this beaker. Then question number one. Question number one is calculate the mass of the liquid. Okay, in grams. Number two, and number two is like B. Calculate the density of the liquid in gram per centimeter cube. So these are the two questions. So how we can solve these questions?
Do 136 equal 48.
Sorry.
Get
So you see,
136
mhm,
to
good.
get 88.
So you see, a measuring cylinder contains 80 centimeter cubed. So this is actually its volume, isn't it? So then what we would do to calculate the mass, first of all, the mass of beaker was this. After putting this liquid in the beaker, the mass increased here. Then very simply 136 minus 48 is equal to the mass of that liquid, isn't it? That is
Yes.
88, isn't it?
Yes.
88 grams. Now to calculate the density, how would you calculate density? The density is very simple then, isn't it? 88 divided by 80, is it?
Yeah.
And what will be the what will be the units of this answer?
Grams per centimeters cube.
Very good, shabash. Grams per centimeter cube. Very good. Okay, so um, next actually is, I guess these questions are very, very easy peasy, lemon squeezy for you. So then we go to the next matter. The next matter is of our topic is the following. Sorry, let me write. The states of matter. States of matter. So here, before actually going ahead in our question, because we have discussed about density, and here this is a very good opportunity to explain you little more about, for example, the gravity. For example, because this is little bit additional thingy that you would be actually liking it. For example, we have you can say uh, like a planet or any star. Okay, this star will have a field of gravity, isn't it? Meaning that a region around this in which it attracts the other matters, isn't it?
Yes.
Yes. Okay. Now the strength, or you can say the range of this gravity, it depends on the mass of this object, isn't it? And
yes,
then how we can actually calculate the mass, because we cannot put a planet or the star on a scale to calculate its mass. What we do, we actually calculate its density, that how dense this actually star is, how dense this planet can be. That actually depends on on you can say the constituents with which this actually planet form. For example, the Jupiter is a giant gas. The Earth and then the Venus and Mercury and Mars. So they are not the giant gases. They are actually like rocky planets, particularly the Mercury and Venus. And then this density, and if we know the density and we know the diameter and we consider that this is a spherical, we can actually calculate the volume, and then we can measure the mass, isn't it? Isn't it?
yes,
Yes. Okay. So now, if for an
yes,
example, if for an example, what happened that we have this the same mass, we have a same mass. What we are squeezing it, we are squeezing it. When we will be squeezing it, then it means that its volume is going down. Its volume is going down and its density is going up. Its density is going up. When its actually density is going up, then that means that the mass per unit volume is huge. Then it means that within this range, within this range, its gravity will be very, very strong, isn't it? The density will be
yes,
very, very strong. Then if for an example that this volume approaches to zero, this volume approaches to zero, what does it mean? That means that this density is going to be infinity, isn't it? And
yes,
if something actually achieve the density of infinity, what does it mean? That if this is going to be infinity, then it means that it is too much dense and there is a too much infinite mass at a very, very small volume. That means that its gravity will be very, very strong, isn't it?
yes,
Yes, particularly at that point. So, what would it be? It will be a black hole, isn't it? It will be a black hole, isn't it?
yes,
Yeah, so this is the concept of the black hole, and that actually related with the density. So that's why I actually explained it here. Now we actually go to our next topic, and our next topic is the states of the matter. What is the meaning of the states of the matter? Mhm.
is it solid, liquids, and gas?
Yes, exactly. And how actually this all happens? That for an example, we say that we have some medium, and that medium is actually, for example, the solid. And in this solid, what we do have, we have atoms, and these atoms are very nicely arranged, and they are very close to each other. They are very close to each other, for example, like this. Now what will happen, that you can, if you will actually analyze this sample, you can see that these atoms, they cannot have a transformation, so they cannot move to the other places. For example, this atom cannot come over here, but only that these atoms, they can vibrate, isn't it? These
Yes,
atoms, they can only vibrate. So it means that there is some kind of a energy in this material, but it is not actually, you can say, as much as you can say that they can move freely around. They can only vibrate at their fixed positions. They can vibrate only at their fixed position, and they are very strongly bound with actually its neighbors, isn't it? So this state is actually the solid state. What is it? It is the solid state. Now if for an example we give some extra energy to this medium, and extra energy in such a way that these actually the atoms, those were very strongly bound to each other, now they are not actually very strongly bound to each other. What they can in fact also do the you can say transition, or they can transfer from one point to the other, they can move within the medium. Okay, they can move within the medium. So it means that, for example, previously we put actually the three rows like that, then this atom maybe it can come over here, this atom can come over here, so then it means that it will spread out. And in this state, what will happen, that the distance between the atoms that will increase, the distance that will increase, and they will not be, you can say, very regularly arranged. They will not be regularly arranged. They will be randomly arranged. They will be randomly arranged. So randomly arranged means that now they are going to get the shape of the container. So if for example your container is like this shape, then this actually the state of the medium will take the shape of the container. But here in the solid it has its own shape, isn't it? It will have its own shape. So then this thingy is liquid, isn't it? This thingy
Yes.
is liquid. So this is the next phase. So what happened, what we did, we said that we gave some extra energy, isn't it? We give some extra energy to this medium, and now these atoms they can actually move a bit more freely, but they still have a bond with each other. They still have a bond with each other. So this will be one material. Now if we actually give some more energy to this medium, then now we are actually giving more energy to the atoms of this material, and now we are increasing the distance between these atoms. They can actually be quite much, you can say, the free to move around. They actually have no particular shape. And so in that case, what will happen, that these are more energetic particles, they can move freely, they are not you can say bound with each other. So what does it mean? So this phase is, we call it a gas phase. This is the gas phase, isn't it?
Yes.
Yes, okay, very good. So now we actually try to understand these kind of things, that what will happen in this all between these all phases. So we said that we actually giving some energy to a solid and going to a liquid, then from the liquid we give more energy and we obtained the gas. So, for example, we do have a cube of ice, the cube of ice. So, what does it mean? So, this is actually, you can say, the solid solid form of water. If you will give some energy, then you will get the liquid form of the water, isn't it?
Yes.
Liquid form of the water. That's actually it's usually at the room temperature. And then if you will heat it up above the 100, up to 100 degrees centigrade, then what will happen, that this will convert into steam, isn't it? Vapors. It will convert into vapors of the water vapors, isn't it?
Yes.
So if for an example we do the reverse, meaning that the energy that we give it, we take it back, we take it back, then it will go back to the liquid, and then from liquid to the solid, isn't it?
Yes.
Very good. Any questions so far, Muzammil beta?
No, sir.
Okay. Now here the question you may ask is could be the following, that you can say that here uh, that what are these processes, what are these processes. For an example, that when a let's start from the gas. When a gas actually going to become the liquid, going to become liquid, what does it mean? from gas to liquid, we will call it condensation, isn't it? This is the
Yes.
condensation. So, what is the meaning of the condensation? That our gas is actually going to become liquid, isn't it?
Yes.
Okay. And then if our liquid is going to become gas, then we call it that if liquid is going to gas phase, liquid phase to the gas phase, and we are talking, don't keep only water in your mind. So just we are talking about everything. We are talking about the matter. We are talking in general. Okay, then liquid to gas, what does it mean? That we are having vaporization. We are having vaporization, meaning that we are vaporizing. We are vaporizing, or you can say we are boiling, isn't it? We are boiling. Okay. And now, if for an example, we go directly from gas to solid, from gas to solid. So, what does this mean? If we go from gas to solid, and how we can actually do from gas to solid, from gas to solid. So, we actually cool it down, isn't it?
Yes.
What is the meaning of cooling? That we are taking the energy, we are taking the energy and bringing these particles close to each other, and then they are developing the bonds with each other and getting a shape of the solid. Okay, so this in fact also known as the condensation, meaning that gas goes to the liquid phase or in the solid phase. In both cases we will call it condensation. Okay, but then if for an example the solid is going to become the gas, so then what does it mean? It means that we are heating it up, isn't it? We are heating it up. But here, Muzammil Beta, the most important point that we need to keep in our mind is the following: that here the solid, here the solid is directly converting into the gas phase, isn't it? The
Yes.
solid is directly converting into the gas phase without actually going to the liquid phase, isn't it? So I will write here
Yes.
that solid directly to gas phase. Okay, directly to gas phase. So this process we call it sublimation. Sublimation. What is the sublimation? The conversion of solid directly into gas. Okay, understand?
Yes.
Very good. But now, what is this process? This one, that from solid to liquid. What will you call it?
Call it melting.
Melting. Yes, melting. Okay. And then what is the opposite to the melting? From liquid to the solid?
Freezing.
Freezing or solidifying. We are actually making a solid, so we also call it solidifying or freezing. Yeah, both are the correct things. Okay. Any question, Muzabbil Beta, so far?
No.
No. Okay. Now let me ask then a question to you. If you don't have a question, then I can ask the question. The question is that we here say that these atoms, they are closely packed, so they are loosely packed. They are very loosely packed, isn't it? Then
Yes.
which material or which phase of the matter should have highest density?
Solid.
Solid. Okay. solid have highest density? Then
then liquids,
liquid, then
gas.
gas. Okay. So the density is increasing in actually in this direction, isn't it?
Yes,
Okay, you're right. Now my next question is that if we actually we have for example we have a water, okay, we have a water, and I put a piece of wood. What I do, I put a piece of wood here, and that piece of wood actually will not sink, it will float over here. And if I put here a stone, and that stone will of course sink in it. Why does it happen? Mhm.
is it because a stone is more denser than the water? But the wood
Uh,
isn't.
exactly. Okay. Very good. You are right, because this stone that we consider that it might have a higher density compared to the density of water. Okay. Or this liquid, in fact, whatever this liquid, if it is a water in this example, then we will consider it water. But this actually also true for every liquid. Okay. So now this wood actually it
Yes,
has a density less than the density of water. Okay, keep this in your mind. Then I am going to ask you another question. The question is that you you already observe that what we do have, for example, we have this water, and on the water we have a big piece of ice. Okay, this ice
yes,
will sink or will it float on it?
float.
It will float. And this ice is actually, you can say, the solid water. And this is the liquid phase of water, isn't it? And we actually
Yes,
say that the density of solid is greater than the density of the liquid. Then why
yes.
actually this ice is floating on the water? Why? Mhm.
Could it be because it's got some air inside it,
Mhm. So,
or the shape?
okay. So you said that maybe the shape or trapped gas in ice. Is it?
Yes,
Okay. Okay. Now let me think about that. What I do, I actually, you can say, frozen the water in a very very nice way, that it is completely ice, and there is even no any there is even no any single atom or the molecule of the gas trapped in it. So this is totally the ice and very very nicely frozen. Okay, understand? Now this is
yes,
out, but this ice will again float on the water. Now we look this shape. So shape does not have any effect, because we know that if it is in the form of the cube or in the form of a sphere, or even if it is a irregular just like a sheet of the ice, even then actually it floats. So then both things are not acceptable. Now you are in hot water, isn't it?
yes,
No, you are not, because you know the answer, but I will actually only give you a hint. The hint is that this actually explained with the density. This explained with density. In fact, the density of solid water, the density of
was it about
solid,
the volume?
sorry, second,
Is it to do volume?
warm, Warm means, sorry, I misunderstood. What you want to say?
I said, does it have to do with volume or mass? Any of
That's
them?
the volume. Exactly. This is to the volume. And the density of solid water is less than the density of liquid water. Okay. You know, actually, what happened? How we can actually get ice? We have, for example, the water here. So when we will cool it down, then we will get actually the ice, isn't it? Is it?
Yes,
Okay. So below be sorry below 4 degrees centigrades, below 4 degrees centigrade, what happened? Water expands. Water expands. Okay, with actually rearrangement of its this of the bond between oxygen and hydrogen atoms. So what I said, that below 4 degrees centigrades the water starts to expand, isn't it? So what does it mean? It means that we say the density is equal to mass divided by volume. Water expands. If water expands, it means volume has increased, isn't it?
yes,
Yes, increased. So density has decreased. So this is
y-
actually a very special liquid. The water is a very special liquid that when you freeze it, it's actually the volume increases because of expansion of the water below 4 degrees centigrades, that decreases the density. That decreases the density. So then it means that the density of solid water is less than the density of liquid water. So this is the reason that ice actually floats on water, isn't it?
yes,
Do you understand now?
yes,
Yeah, very good. So if, for example, that we are here in somewhere enjoying our holidays, and we are on some coastal areas, so this is the sea, and if this uh, sea has you can say this salt level, the salt level is very high, meaning that this water, you know that the water of the sea is saltish, isn't it?
yes,
Because of actually dissolved salt in it. If the level of salt is too much in it, then what does it mean? That this is not only the water, so it contains a lot of salt, and then its density will be high, isn't it? The density will be high, and if its density will be high, then it will be easy for us to swim in it, because then we may not actually, you can say, sink very easily in such water, isn't it?
yes.
Yes, very good. So now it is your time to ask the question.
Hmm? I don't have any.
Do you have any question?
No.
Okay, so so this actually the all the things that we discussed so far. So these are also, you can say, the kinetic theory of matter. What is it? The kinetic theory of matter. What the kinetic theory of matter? Kinetic theory of matter. So kinetic theory of matter, it is actually the theory that explains that how the particles, you can say you can say behave, that what is the kinematics of the particles of solid, liquid and gas. In fact, we have already discussed in our first slide that if the particles, they are fixed, they are fixed and they actually held next to each other, the particles, they actually held next to each other. So this means that in fact there is a strong bond between these particles, isn't it?
Yes.
Yes, so these particles, they have a bond with each other, and these particles are actually fixed at their positions, and only thing that they can do is the vibration, isn't it?
Yes.
Vibration. So what kind of energy would they have? They will have vibrational energy. Vibrational energy. So that will define its, you can say thermal energy, or you can say the temperature as well, isn't it?
Yes.
Okay. So then the particles of a solid, particularly in the liquid state, a liquid phase, they actually still contact with each other. So meaning that if these four particles, we took an example, so then these particles could be, for example, like this way, and they can have the still some kind of interaction between each other, but now they have additional energy. They have additional energy, so we give some additional energy, so then these particles can move randomly, can move randomly, isn't it?
Yes.
So randomly, what in what there is one thing that we must actually keep in mind, that these liquids, they will take the shape, isn't it? They will take the shape of the container, isn't it?
Yes.
Yes, of container, because they actually still have the bond with each other. They cannot go very much far away from each other. And then we discussed that if, for example, we give some more energy to these particles, then these particles might go like that, and there is in fact not really much interaction between the particles. So these particles can move faster. They can move faster compared to the particles of liquid, isn't it? But in a solid, we have only vibrational. So this is also translational energy is also there. And here they can actually random motion, random motion more than liquid, more than liquid, because in a liquid we said that they can actually move randomly, but here in the gas they can move, we can say with a more higher kinetic energy, isn't it? So the of kinetic energy of the particles of the gas is much higher than the kinetic energy of the liquid. So then you can say the kinetic energy of the liquid particles are actually much higher than the kinetic energy of solid particles, isn't it?
Yes.
Any questions so far?
No, sir.
Okay, very good. Then let me have a look. Let me have a look on the questions. Exam type questions. So they say, for example, one question is that describe the changes that take place in movement and arrangement of particles in an ice cube and the ice when the ice melts. So this is simple. You can explain first, because if, for example, this is like just 2 marks question, that when the particles are in the ice form, then water molecules, they are more bounded to each other. But when we give extra energy, they are getting now the additional energy, they can randomly move, but there is still some kind of a interaction that will keep actually it in the close contact to each other. They will not be as much random as they can actually can achieve in case of the gas state. Okay, understand?
Yes.
Explain using the kinetic theory of matter why liquids and solids are much denser than gases. So you heard this question. So why, using this concept of the kinetic theory of matter, why liquids and solids are much denser than gases? So what will be your answer? So this is a 4 point mark. So four mark question. So why solids and liquids are more denser, more denser than gas. Mhm. How would you explain that?
In a gas, the particles are free to move anywhere, so they're not in a thingy container or a fixed position like
Uh-huh.
a solid and a liquid.
Yes.
That
So
means
because
that the volume
Mhm.
of it,
Mm.
it could be the same, but the mass of a solid and a liquid would be higher than the gas.
So then here you could actually also take this first point is that we know that the density is equal to mass divided by the volume, isn't it?
Yes,
Okay. If this is the case, then we can go to the next point that in solid, the particles, because we actually need to take all the points of kinetic theory. Okay, the particles are are fixed, at their positions and strongly bounded and closely bounded, or you can say packed. Okay, so then the mass, then that means mass per unit volume is higher, isn't it? So then these are 3 points. So in that case, these 2 points you can explain again for liquid, isn't it? That the particles are, so in liquid, the particles are actually still have, you can say, the bond with each other, but they can move randomly. They can move randomly. So then it means that they can uh, they can have a more distance between the particles, so the volume increases. So volume increases. But in gas, here, in gas, particles particles are almost free to move, free to move. So volume is much higher. Then or you can say the mass per unit volume is much lower, isn't it?
yes,
Yeah. So in this case, so when you see our question is a 4 marks question, then we need to give, you can say, the 4 points, and those 4 points must be explaining our question. So minimum 4 points, isn't it? Minimum 4 points. Okay, understand?
yes.
Yes. Any question, my dear?
No, sir.
Okay. Then we will actually next time will explain the specific latent heat. Okay, and
Yes,
gas pressure and temperatures, about the gases, that how we can actually uh, do that, and then this Boyle's law and Charles law. Okay, and this chapter will be finished then. Okay, if you don't have any question, can we stop here?
yes,
Yeah, I guess this is very good for today. Okay, dear. Do you want these slides?
yes.
Yes. Then I actually saved them and I will send to your brother. Okay.
Okay.
Okay. Very good. Thank you very